So like I said in your chapter 11 talks about the special systems owner circuit. The reason why they call them owner circuits because it is a multi-occupant building that occupied by many people or occupants, and the common places have to be fed from a common panel. So that's why they call them the owner circuit. Here's a few things, guys, we're going to talk about. Now, Jamie, my friend, you can imagine why the elevator has to be on the owner circuit because it serves the whole building with those 5 or 6 occupants in it. Then we have the heating and the lighting only for the public areas. All the hallways in a commercial building that's occupied by multi-occupants have to be fed from the house panel. Everybody understand where the house panel is, feeding all the common spaces. Then we have and also some loads, because they're so important, they have to have an optional standby power system, backup system like a sump pump. What they did is have a generator. If the sump pump in the building, if the power is to go off, the sump pump will go on the generator if the sump pump need to be worked. So these are a few loads, guys, that they have on again, one more time, few loads that they have on the owner list. Heat. So the heat for the building, if you go to in a building where there are multi-tenants in the building, commercial building, the first thing you're going to think, all the common areas have the light and the receptacle have to be in a common panel. All the heating and cooling of the building, if it's central heating and cooling, has to be coming from a commercial building, right? And also, if you have a sump pump or certain things like this that for the basement have to be from the common panel. Okay, let's go talk about the lights. The first thing that they did, guys, in this commercial building, let's minimize that one. They put the common lights. They put them on the owner. It's owner responsibility for the hallways and so forth. And this is really one way, Jeff, of putting the common lights on different type of control. Look what they did. They did continuous duty. We no longer do this. They used to, guys, do the hallways. They feed them from a circuit breaker, no switch. So they are on all times. This is going away because we're becoming environmentally friendly and want to save energy. So continuous duty means you just throw a circuit at them. Remember when we do a Revit, what did we do for lights? We circuit tagged and switched. So you don't switch, you don't tag. You don't switch, right? You just circuit them. So it's not commonly used. Manual control, you're looking at it right there. Switch there on and off. Auto control, occupancy sensor for lights or a floating switch if it's the sump pump that you have that turns on and off by itself. Timers, photocells for the outside door, and exit signs for the building. Did we put the exits? Did you guys put the exit signs on the switch? I hope not. So exit signs usually is wired directly from a circuit. So these are the type of the control that they have in this commercial building, and you can relate to it, right, Jamie? You can relate. We did every one of these in our building. Okay, so here's how then they go through where did they add where did they put these different controls? For example, here's what they suggest: continuous duty, meaning circuit breaker and feeds the light. That's continuous duty. Look where they did them. Okay, you can agree or disagree with them. They put them in each stairway to the second floor of the commercial building, installed at the top of each stairway to the second floor of the commercial. So the stairways and hallways, they use, guys, to put them, especially the stairways, they put them in a light and turn them on at all times. That's a good application if you go in a commercial building. Again, it's not really with the energy code now. You have to dim them or do something for them. For security reasons, sometimes also stairways, they keep them on at all times. So if you have a stairway, a good application is to turn them on, one application. So what do? If the light is directly powered through a circuit breaker, no switch. Can I have thumbs up, Chad? No switch? Got it. Manual control. Manual control is you put the light right here, you put a switch, and you bring a circuit to it, right? And again, we're showing multiple lights here, of course, with multiple switches. That's a manual control. Where did they do it? They did it in the corridor, the second floor corridor, and the utility and the toilets. Now, in our toilet, Andrew, what did we do? We put an occupancy sensor. I want to remind you guys, what we did is more environmentally friendly. Occupancy sensors, timers are the future, right? Like we said, everything is going towards saving energy. So Areas like this, like in the bathrooms, we put an occupancy sensor there. I want to remind you, in the utility room, later on, guys, you can't have an occupancy sensor in the utility room. Anybody knows why? Did you guys put an occupancy sensor in the utility room? You can't, because if you have an electrical panels, you have to have some type of manual means of turning the light on and off its code. So if you have an occupancy sensor, you have to have a manual override. We'll talk about this one in a second. So remember, in utility room, you have to have some type of manual control over it. Because of auto control. When they did auto, again, this is not light, but they have a sump pump. Obviously, you don't want to turn the sump pump on and off. There's a floating switch that controls the sump pump. That's their auto control. Auto means no, Brian doesn't have to push the button. If the water goes higher than a certain level, the floating switch triggers a little contact, close the contact, the pump starts pumping water. When it goes below a lower level, it stops, right? You've seen the sump pumps, how it works. Timed control. They did a time control, guys, on fixtures, aka luminaires. Look where they did them. And so at the entrance of the commercial building, they put it in a timer. And they put astronomical clock. So they put a time clock or astronomical clock that can adjust it to turn on and off at a certain time. Located near the owner. So that's where they put them. The luminaires at the entrance, they put them on an astronomical clock. They put also the parking lot, guys, on astronomical clocks, so they can turn them on and off, and they can adjust it summer, winter. So that's another application. Here's the clock, time control clock. There's so many ways of doing it, guys. This is old-fashioned, where you have a synchronous clock, and the synchronous clock keep timing it. You bring it 20 amps to it. When it times out, it closes this contact, and these lights go on, right? This is a good example of astronomical clock. So keep flipping, flip. You're feeding it. When it kicks to between, what are we going to say? Let's just say from 6 o'clock in the evening until 6 o'clock in the morning. I want the parking lot light to go on, right? So you adjust it, and then at 6 o'clock in the evening p.m., this will close. 6 o'clock a.m., it will open. You can see here's one way of wiring it. These two are in the same device, obviously. And these two circuits could be the same circuits. And they're putting them in a standby system. They're putting them in an emergency system, these lights, on an emergency system light. Photocell. The way they did the photocell, guys, the exterior of the building, exactly like we did. We put our lights on a timer, right? You can also add a photocell to the lights, so it can turn it on and off, turn it on at night and off in the early morning. So that's what they did. A few things about photocell, guys. It senses the existence of a light, it magnifies the signals and turn a switch on and off. So how do you wire that boy? You come over here. You put an inline photocell here. I'm just going to summarize it a little bit. Contact here. So here's my photocell. Here's my contact here. And then there's a little relay here. And there's a lot of electronics here that come in controlling this relay. And then from here, you go to all your parking lot lights, right? So here's what happened. This takes some juice here to cook the electronics. And if it sees where we are, the photocell, if it's dark, it doesn't see light, it energizes this little coil electronically, sense it, energizes this electronic coil, and what happened here? Close this contact. When this contact is closed, what did you get? You get the light. I'm only showing the phase. Of course, the neutral is going to be coming from here. So the light will go on. This is typical for timer or occupancy sensor or any of one of them, guys. There is a mechanical. There's a sensor senses, create the signal will close the contact, either electronically or mechanically, shut down the contact, and you got yourself a control over your lights. Any comments, guys, about photocells? Commonly used in parking lot, timers is another place, astronomical clock is another application for parking lots. So when Aaron becomes a big designer and goes to have a parking lot, your first option, a lot of them, guys, have photocells at the top of the fixture that control them individually. That's one way. And they also have a timer, so they can control them all together. Photocell control individual fixtures right at the top of the fixture, and also a timer that controls the whole circuit. Any comments, guys, about these? That's an example of doing the parking lot. One example. Exit signs. For exit signs located by the local code, do you remember how we did when we did the exit signs, guys? We put them every exterior door of a building, we put one. Typically, if there's a hallway, I believe every 100 feet, in like big hallways, every 100 feet you put one. Every stairway, at the top of every stairway that takes you down, you put one, if it's a bigger building. So 100 feet, every stairway, every exit, and then you kind of walk yourself through the building. If you have rooms, if you have a room, a multi-occupancy room, like conference rooms that has 100 people or more, assembly rooms, you put exit signs on every door, at least 2 doors that come to this assembly room by building code. So that's where we put our exit signs. Exit signs. Do we circuit them? Yes. Do we switch them? No. What voltage can I get them? You can get them from 120 all the way to probably 480 voltages. And what they do, they have a backup power, guys, always, right? Battery backup power, and they're connected always. Can you guys? Yeah, let me draw that one because a lot of people get confused with this one. Your backup power for exit signs. Here's my circuit breaker, 20 amps. Here's all my fixtures, right? In one area. Here's one area. Here you can see that. Now here's my exits. Let's just put a door here, and we need to have an exit sign next to that door. Here's what you do, guys, when you have an exit sign. Let's put 2 doors. Here's one door here, and here's another door here. So what we do, here's my exit sign 1, here's my exit sign 2, and I come. Oh, I need a switch. Here's my switch to switch these 2 lights. Come over here, switch in, right? Here you can see the switch. You come from the line side of the switch, bam, bam, and I'm showing only the hot. And you come from the line side of the switch and you feed these 2 lights, the line side of the switch. You don't switch them. Can I have thumbs up, Chad? That's what we did in Revit. You're repeating yourself like a grandma, right? Okay, so that's basically what they're saying. You feed them from the local circuit, and ahead of the switch, Sump pump. Sump pump again, remove the water. You know what the sump pump is? If you have a flooding, natural flooding, or break-in pipe in your system, or sewer backup, it's supposed to take all this stuff and pump it outside. It's critical item, right? Because you flood your building. So what do they do? If you have a generator, an emergency panel, like the owner equipment, you back up. You put that sump pump where? On your emergency panel. Do we have a generator, guys, in our building? Yes. So this pump is actually going to be on the generator because the generator is going to pick up, right, and picks up the building. So it becomes a legally required standby. This is a legally required load. Required if you have an emergency system to send it to put that particular load on the generator. Floating switch, you guys have seen floating switch. If it keeps going up means it's filling that little hole of water, right? It triggers a couple of switches here and start the pump. When it goes down, it opens contacts. Everybody knows how this floating switch works, right? That little ball keeps going up. It's like what do you call the bathroom thing they flush? It's called the float. The floating switch. So it goes up, it triggers in, and goes down, triggers off. So we go up here, we'll get you on at a certain time, we'll get you off as it goes down to a certain level, right? Mechanically interface. Okay, sump pump. So they talk a little bit here about the sump pump, guys. It has a manual motor controller, and have a floating switch controlling it. So the floating switch is really mechanically closing and opening contacts to open and close the contacts in the control circuit of that pump to turn it on and off. So different ones have an integral switch with them, but that's a couple of things. A floating switch controlling a controller for them. Water heater. What they did, guys, in I think in the bathrooms of this commercial building, they have a water heater directly wired from 120. From 100, here's 20, and this is my water heater, and we size water heater, guys. And then they also have a space heater, same thing, 120, a space heater, number 12, and 20 amps. Typically, these are all number 12, 20 amp single phase, right? Typical of all these space heaters and water heaters in the bathroom. If you're building a small, guys, and you don't have a central water heater, that you can centralize it. So this is the one way of having water heaters. Take the water heater in right into that location. Any comments, any questions? Who cares? Aaron, you have a multi-occupant building. You are doing the design for it. Because our building that we're doing right now, guys, is single occupant. So we don't have to worry about this. Zach, why do you think we didn't worry about the heaters in the bathroom in our commercial building? Because it's owned by one owner. We have a chiller and a boiler, and the boiler will heat the whole building. Those guys have also a chiller and a boiler, but certain areas need more heat, so they assigned a space heaters as well as a water heater to feed these areas. The elevator. Okay, for elevators, there's special animals, guys. So you have an overcap protection device. Then by code, most codes require you to have a fuse, disconnect, and then the elevator pump itself. Can you write yourself a note here? I can't remember what's the full load current of this elevator. So if you go to this article that talks about elevators, here's what they require you, Jeff. They require a dedicated branch circuit that feeding a fuse disconnect that's right next to the pump, the elevator pump. Can I have thumbs up, Chad? How do you size the pump? It's a horsepower, right? Say if it was a 50 horsepower, I hope, guys, you know how to size a branch circuit for a 50 horsepower. We all know, right? 125 times the full load current, plus the fuse and the circuit breaker, 175 if it's dual element time delay fuse, 300 if it's non-time delay fuse, 250 if it's a inverse type circuit breaker, and we size the whole system. So that's the only thing is they require a disconnect fuse right next to the equipment, regardless of what the circuit breaker. So that's what we did. Please write to yourself this thing about the elevator. Some elevators have a machine room. Others, guys, they don't have a machine room. Everything is in that shaft, the elevator shaft. They need also another thing. They need a separate circuit for the light and the fan within the elevator. So what they do, guys, they take another circuit here, a 20 amp circuit, and they feed the car, the elevator car with a 20 amp circuit. Everybody understand what the car going up and down, there's heat and cool inside the car. So they feed it with a dedicated, at least one circuit, 20 amp circuit. 20 amp dedicated to the car that goes up and down. Any comments, any questions? So most of the time, Jeff, if we have an elevator, like we didn't ever done with it, we take a feeder. Typically, they take a feeder, say 100 amp, and to a panel. This is a 100 amp panel. And from this, you feed your elevator, and you feed a bunch of loads related to the elevator. And this will be right into the room, or the elevator room, dedicated for a panel, small panel for the elevator. Very commonly used. Any comments, guys, about the elevator? Remember, disconnect fuse next to it, plus, of course, the overcap protection device, the branch circuit, and you need a circuit for the car that goes up and down. The car that goes up and down.
What's a common voltage for the motor that actually powers the elevator?
I think this system is 208, three-phase. Typically, all of them, when you have an elevator, you're dealing with 208 or 480 system, three-phase. Three-phase. Then the last thing, so we know what the elevator is. Some motor, we size it, fuse disconnect next to it. Electrical boiler. This is the boiler that's going to heat most of the building, guys. This is really interesting. Look how big of a boiler they have. This is an electric boiler, not a gas boiler. We have a Dunwoody. Did you guys do a Dunwoody? We have a gas boiler down there. If you go there, the whole gas, that big gas have a 20 amp circuit controlling it. That's about it. The building that you guys are doing with me right now in Revit, it's a gas boiler. That's why, remember that boiler control circuit was a 20 amp? You guys remember that? Everybody knows why 20 amp? It's a gas boiler. These are electric boilers. They're burning electricity to generate heat, and they're using electricity to control the heat too. So that's an interesting. So we have full, here's the load. This is in this, when you size it, guys, 1.25 times of full load current, piece of cake. So completely, it's typically completely wired. It's used to heat the whole commercial building, or all the areas of the commercial building, and it has a sensor. The way, I'm not going to get an interface, the way they do it, guys, they have a sensor, an outside sensor. If the temperature in Minnesota goes below 65 degrees outside, it triggers the boiler inside the building to start heating water, so it will circulate this water into different locations so it can heat the building. Can I have thumbs up, Chad? That we know that this boiler is boiling water. This water will be circulated through pumps, and when it's circulated through the pumps, guys, they blow air through these circulated pipes, and will get you hot air. That's how you get your hot air. But there is a sensor that triggers it to start, though. The temperature outside have to be cold enough for the boiler to start, so it can get you heat. That's what they're saying here. There are zones, guys. These heaters have zones. I think we have a nice picture. And whether it's a thermostat, the way they do it, guys, they have a thermostat in every occupant area. The thermostat calls for heat. It will start the pump. The pump will pump hot water into that area. It goes through a system, a blower, and blow air through it, and you got yourself what? You got yourself a hot air. You got yourself a hot air. How do you wire it? Wiring it exactly like continuous load. How do you wire a heater? 1.25 for the branch circuits, 1.25 for the overconduction device. Done. So if you guys want to do if you take the 200 kW, divide this by 208, don't forget 1.73, give you I, take your I, multiply it by 1.25, this will get you a conductor and also an overcurrent protection device. Done. See how easy that? We've done it a couple of times. So that's my heat requirement. Here's how it works, guys. This is really interesting. See, if one area calls for hot, right? It's cold and I need heat. Here's the thermostat will close. Can I get you guys to see that one? Then the thermostat will close. Then it will energize this relay. Can you guys see that relay? When this relay is energized, it closes this contact. Now this contact has a pump. Remember that recirculating pump that you have in your project? These are recirculating pumps that circulate the hot water inside the building to get your heat. So first the thermostat has to call for heat, close the coil. Now the coil is energized. This will close the contact. Now the pump is pumping hot water into the insurance office. Inside the insurance office, guys, it goes to a radiator. It's like a radiator. Then there's a fan that blows air right through it, and got yourself what? A hot air, or air handling unit. In our project, we have air handling unit. We circulate the hot water to the air handling unit. Inside the air handling unit, we blow big blower blowing air right through it, and from the other end, you get hot air. Can I have thumbs up, Chad? I usually bring guys, when we talk about next project, I bring our designers, mechanical designers, and they talk to you or with you about the whole heating cooling system, how it's put together. Okay, but this is just warming you up for that. How do you do the electric heat? I will remind you guys, here's an overconduction device, here's a disconnect for it, and there's the heater. That's it. Here's my disconnect, and here's my overconduction device. How do you size this? 1.25. How do you size this? 1.25. How do you size this? 1.25. Does that sound hard? 1.25 times what? The full load current of the heater. You size the overconduction device, the conductor, as well as the disconnect. Done. You have to have a disconnect within sight of the heater, or it has to be locked in the open position. Typically, you put the disconnect right next to the heater, so you can disconnect it. Thumbs up, Chad. We've done that. Remember last project that we worked about heaters and we sized them? Nothing really comment about them. Okay. Talked about overconduction device sizing it for the electric heaters. We talked about the article that talks about it. 424 is the article that tells you all the stuff that we did. Option electric boilers, each have heating thermostat. So inside the building, each will have thermostat. The thermostat will kick in to get you the hot water. Supply from the okay. Here's what the circulating pump. This is me. I want you guys to wake up before I put you to sleep. What they do for the circulating pump, the one that circulates the water, they put them in the emergency circuit. Anybody knows why they put them in the emergency circuit? Because in Minnesota, if it freezes, it could damage the system. So if the power goes off, you have to have a generator to circulate the water inside these pipes. Otherwise, it will freeze and bust the system. So that's why if you have an emergency system, they put them legally required standby system. They throw them on a generator. Because of what? Sub-freezing weather. And we in Minnesota are a good example of that. What does the freeze do to your equipment? Damage the boiler, bust them, and the piping and so forth. Here's how a commercial boiler look like. Unreal. Look at that. I have two conductors, 500 kcm each, to feed this electric boiler. Can you just see the amount of heat that's going out of the electricity that's coming out of this boy? And then they have contacts. So if everybody's cold at the same time, they start closing these contacts. Bam, 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 bam. And every time they close the contact, they're burning more resistors. Can you guys see that? Every time they close the contacts, burning more resistors. What does burning resistors mean? You're creating more heat. Why? Because there's a signal coming here asking for more heat, and these resistors that's burning right now are not enough to get you that heat, so they start closing more and more contacts, burning more and more resistors, or opening more and more contacts to burn less and less resistors. Can I have thumbs up, Chad? This is how they guys control an electric boiler. And all the junk that you're looking at here is where? Internal to the equipment. Internal, you don't mess with it. What we provide is right here. This is all internal. All what we provide is wires to the system. Wires to the system. Wires to the system. Any comments, guys? Any question about the boiler? I thought that's one of the most interesting pictures about an electric boiler, because we don't do a whole lot of electric boilers. Now for the building, Joe, the building that you're doing right now, see all these, I can't remember, anybody remember what the circuit, was it 7, I can't remember what the size of the actual size of the boiler. Anybody has the riser? What's the amp size of the boiler circuit? I have two, I think it's 800, yep, 800 amp, right here. God, Chad, it's right here. So this is coming actually from an 800 amp. This is an 800 amp. 800 amp at what the voltage? 28120. 800 amp feeder carry is feeding just the boiler. Am I the only one who's excited here about 800 amp feeding one boiler? Are you guys, do you know what the 800 amp? What's the size? Can you guys tell me what, Jeff, do you remember what the size of the panel for the whole building that you were working on, our commercial building? 500 amp at 28120. Look at this. This is 800, twice, almost twice. Twice the size of the service panel for the commercial building that we did is dedicated to the boiler. Do you understand now why the commercial building that we're working on, we created a gas boiler for it? Cheaper in Minnesota, it's cheaper to burn gas than to burn electricity. That's why a lot of boilers that you go guys in a commercial building, they're all gas, natural gas boilers. Cool? Any comments, guys? Any questions? So imagine if this was inside your building. You're going to add the 800 to the 150, so that will get you what? It'll get you to 1300. You end up with, if 13 is not standard, probably will end up with 1400 amp service coming to your building.
Or you don't have electric water heaters around here in your house.
And the other thing, yeah, electric water heaters is not commonly used. They use them, but not commonly used because natural gas in our area is cheaper. Natural gas is cheaper. Can I get you guys to understand how this sucker works here? See how nice it is? How do you size all this 800 and everything else? Remember, the full load current of the heater, boiler multiplied by 1.25 get you the conductor, the overconduction device, and the disconnect. So all in one. Done. Yeah, I want to emphasize, you can see these fuses. They fuse them separately. So if this is to short circuit, look at that. If I have to short circuit right here, do I lose the whole boiler? Do I lose the whole boiler if I short circuit right here? No, these fuses will open, isolate this section from the boiler. they section the resistor. So if there's a short circuit in one section, you don't want to lose the whole boiler. So it will open that section, it will alarm, and then the technicians will go there and fix it. Cool. So that's okay. So that's all what I have, guys, for you. Let me just show you a couple of pictures and give you a quick break here. I don't know if we missed. We talked about this one. Talked about this one. Here's the photocell. The way the photocell guys work. You bring the circuit into the photocell, and it senses, when it senses that there's a dark here, it sends the signal, closes that contact, bam, the lamp goes on. You can see all of them guys have a sensor, sense, close the contact. All of them, timers, photocell, every one of them. Okay, so that's your photocell. This is your sump pump. And you guys see how the sump pump has a disconnect overload device. This is the easiest way, the cheapest way of controlling a pump. You have a disconnect with an overload protection, and then you turn this on, then this will control it, right? When calls for more water to close this one. This is inline floating switch, right? High voltage. So then you can dump the 120 volt across it. If you graduate from your friend Dunway and you don't know how this control circuit works, you should ask your friend Chad for a refund. Really do. So this fuse here will protect the conductors, the disconnect required by code, the overload to protect it from being overloaded, and then this sucker here is what? Your controller that open and close. Cheapest, easiest way of control. Typical. This is typical for a lot of sump pump guys. Dwelling is no difference. Okay, so here's the sequence controller for, this is for boiler temperature. The boiler, now we get into more control, guys. When you do the boiler, the first thing they do, I want to remind you guys, can you see this, the outside sensor here? The outside sensor, this boiler would never work unless, what is it, 65, I think? It says 65 or lower than 65 or less. The boiler starts boiling. If it's higher than 65 in the summer, the boiler doesn't even kick in. So suppose as it was 70 and kick 10 here to cool, and then we have low water cutoff, we have high temperature control, and we have boiler temperature control. So all these guys are your safety feature inside on-off switch. If you turn it completely off, here's your circuit that goes into it. Everything that you're looking at here is your control circuit. That control to your safety circuits for all these for the boiler. So if the temperature goes higher, if you have low water cutoff, the water is not circulating, you shut it off, right? Otherwise it burns itself. Boiler temperature control, the boiler goes higher than a certain value, it shuts off before it burns itself. High limit control, higher limit, I guess, of water, it will shut it off. All these are sensors to control what's going on in the heater. Any comments, any questions? And then, of course, you have then Jeff, you have the thermostat that control the pumps. Remember, the pumps are sitting right here waiting to get a signal to close, right? A thermostat signal from an external thermostat to close this contact. Any comments, guys, about this control sequence for this? So, where's Darren? Darren, remember the boiler control panel that you guys were talking about? Where am I going to put it, Chad? This is the boiler control panel. Can you guys see it's at 1 a.m.? That's what they were talking in our project. Just one circuit to get you all these control for the boiler. Can I have thumbs up, Chad? We fully understand that? Now, our boiler did not need also a power circuit to the boiler because it was gas. This boiler needs two circuits, one for control and one for what? For powering it. Thumbs up, Chad? Cool. Okay, so these are things. Okay, thermostat. This is circulating pump. Okay, we got that one. Okay, the last thing I want to talk about, guys, is this, how the thermostat works. I don't know if you guys can see it. Here's each one of these thermostats is going to a pump, circulating pump. When the temperature, let me just draw that one very quick here. Come over here, and thermostat will close. Here's a contact here, and it comes down. Where is that one? Let's just go take just the hot, and coming down here, all the way here, right? and coming all the way directly to the pump, right? Can you guys see that? Now here's the thermostat. When the thermostat calls for heat, it sends the signal. There's a coil here and wire to the thermostat. Okay, the thermostat energizes the coil. This is closes the. Now the pump goes on. When the pump is running, it starts taking. Now this is water. What you're looking at is water. So it starts pushing waters through these pipes. Right, hot water. Right. So now I'm pushing water through these pipes. Then they have a fan. This is a fan, and the fan blows air through these coils. They're water coils. Through these coils, right? Here's hot water and throwing the air through these coils. What happens if you throw air through a hot coil? What happens on the other end? Get yourself heat. Unless you have radiators, which is they don't have a fan. But typically, all this junk that you're looking at here, this is what we call air handling unit. Remember that air handling unit business? It brings water to these water coils. Inside it is big blowers, blows air through these coils. Got yourself heat for your building. And why do we have 1, 2, 3, 4, 5 of them? Because we have 5 tenants. In our building, Jeff, why do we have only one? Because we have only one tenant in this building. We heat the whole building exactly the same. So we have 5 controllers to control 5 different heat in 5 different locations in a multi-occupant building. Any comments, any questions, guys? Any comments, any questions? When I was working at Elevate back at Jeff, and with my friend Joe, the first thing I did, because it used to confuse the crap out of me, the whole heating cooling system, I went to one of the mechanical engineers, sat with him, I said, could you please explain to me how the chiller talks to the boiler, to the air handling unit, to the cooling tower in a commercial building? You don't need to know that, but it really, as an electrical designer, it's really good to know how this system mechanically works. We have a boiler that boils water. We have a chiller that chills the water. We have an air handling unit that receives hot or cold water, right? And we have fans inside it that gets cold or hot air, depending on the season. And all these are interconnected together. So it's really interesting. I have a really good presentation for you guys, not now, in the spring, about how the mechanical system is put together. Exactly like your central heating cooling in your house, you guys remember? Except it's in a bigger scale. Then they throw a cooling tower at the top. So it's really interesting. And we don't design the cooling tower, but we will be involved in almost in every single power at least, and sometimes control too. Control circuit for it. Okay, a couple of timers, thermostats, contacts, the pump. Okay, that's all I have, guys. Any comments, any questions? Any comments, any questions? Let me close that one. So we'll give you 5 minutes. And my next one is going to be really even nicer because it talks about panels and clearances from the panels and so forth. Give you 5 minutes quick, please.
Chad, is that, go back a couple there? Other way.
The other way, okay. One
Two
more?
more, something like that. Couple more.
Let me know.
This one, is that, the photocell, is that running on, is that like 24 volt, like relay?
Yeah, you're bringing a 24 to cook the electronics,
Right.
because there's electronics here being cooked, right? And the sensing mechanism is burning at 24, and when they take it, they convert it to DC, I believe.
Okay.
Yeah, so you
Yeah,
need
just
to
'cause
power.
I mean, like where the wire connects between there,
Yeah.
one coming from the lamp, but just.
They're not showing a lot of stuff here. Yeah, you bring 120 to it. Out of it, it comes also 120 to the light. Inside it, they take the 120 and they convert to different voltages.
So there's actually like a transformer in there?
I think they reduce it to a lower voltage DC. I believe they do in DC. Because I think they sense at the DC level and then they convert it back to AC. So. Okay. All right, let me see here.